How are you guys? So I wanted to talk to you today about what Discovery Live is and how we can use this new technology in order to communicate effectively to engineers that may be non-technical. So first starting off, what actually is Discovery Live? So ANSYS Discovery Live is an environment that allows for instantaneous simulation. It's tightly coupled with the direct modeler within SpaceClaim, which enables very quick interactions with the actual design and the components, which allows us to rapidly understand what's happening and gives us very quick engineering insight. It supports fluids, structures, thermals, and vibrations, applications, again, allowing engineers to understand the design and get instant feedback. We're just going to have a look at the fluid side of things today. So regarding some of the capabilities, it's actually been built from the ground up to run on GPUs, so it's very different from the traditional traditional kind of softwares that are out there. I'm actually going to be using my laptop, which has a P4000 to run it. It's very easy to use. It has very intuitive tools. It's again enabled by geometry, so we can start to play around with the geometries and add and remove components, which I'll show you later on. We can interact with the actual results and understand what's happening, and we can gain some more intuition about what the product is and make a lot of quick design changes. So there are two aspects that we can look at. We've got external fluid flow, which we're not going to go into too much detail, but we can use that to understand and visualize what the flow structure is around certain components, look at things like recirculation regions, and also understand things like pressure drop, drag, or lift. We can also have a look at some internal flow, so I'll show you two examples around that. And again, understand things like pressure drops through pipes and what's happening around these situations as well. So how is this tool actually used, and how do we recommend use this tool as well? So this is something that you'd use before you go into your fluent analysis. It's very quick to start up and run, which you guys will see. So we can actually start to look at the flow features. We can understand how the flow actually interacts around here. We can look at we can create things like bodies of influence, which is required for some of the CFD out there as well. We can run things like parametric boundary conditions, and it's again, because it's very quick, it's an excellent communication tool for non-technical engineers. So if we kind of go into it, this is the home page for Discovery Live. One of the first things I want to show you is just some internal CFD. So this is just very basic, just to show you guys kind of what we can do. Oh, well, you guys can't see that, so probably not. Cool. Sorry, this is Discovery Live. We've got some internal CFD, and I want to do a quick simulation to help you guys understand what you can really get out of the software, and then we'll take it to something a little bit more complicated. So I'm looking just to set up an internal CFD problem, and with a couple of clicks, I can actually start to set up my problem. So we can see as soon as we've got that going, we've got our boundary conditions that have been initiated. On the left-hand side, you can see what they are. So I've got a flow velocity coming in at around 0.5. I can change that very quickly, so I can start to change the boundary conditions if I wanted to. And I've got my scales on the right-hand side that I can start to toggle. I can also have a look at some different post-processing side of things. So it's, again, this is very interactive. At the moment, we're having a look at what the maximum velocities are around here. I can have a look at what the surface value is, and it'll create this plane for me. I can then start to move the plane around, and I can have a really good understanding about kind of what's happening around these flow regions. I can also have a look at things like isosurfaces. So again, I can use this to focus on, say, regions of high velocity, where there might be. And again, like before, we can also look at things like velocity. I can also have a look at streamlines. So this is, again, showing off kind of what the streamlines are and what they're doing. So if I just reposition this, I can hit play. We can see we've got streamlines that are kind of passed from the inlet. We can kind of clearly see that we've got a lot more flow that kind of goes to this bottom section than it does to the top over here. We can also kind of see that with this particle flow over here. We can, this is almost like we were injecting particles into here. Or we can also have a look at what's called a direction field. So it overlays the velocity as well as, like a streamline on top of that. So a couple of things that I like to do is, again, number one, so understand what the actual flow velocities are on each of these surfaces. So I'm just going to have a look at, I'm just going to stick to the surface contour at the moment. I want to have some sort of monitor. I'm going to look for velocity, and I want to look at the average velocity on a face, and I can select this face and hit tick. We can see that we've got a transient analysis. You can clearly see the mean velocity is changing very quickly. We can just make a duplicate of this calculator, and we can edit the location to also have a look at the top section up here. Right, if we just minimize these, we can use it, we can see it as a probe. We can clearly see we've got quite a bit more velocity at the top, around mean velocity is around 0.5, and the bottom here is around 1.4. So again, like we were talking about, it's a direct modeler, so we can start to make some sketches around here. So I've got these design components that allow me to sketch. So on the actual component, I think I might design a baffle. Maybe it's going to start around there. I don't know, maybe the angle's like that and it's that big. I can go from a 2D component into something that's 3D very quickly, so I can kind of pull that out. And just go back. And as quickly as I've actually made that geometry change, I can see that the flow is actually updated as well. And we can clearly see now we've got changes to the flow regime. So we've got less velocity kind of coming at the bottom, or we've got this area that's pulling more velocity to the top section, to our top outlet. Again, I can have a look at my contours and kind of have a better understanding about what's happening. So again, I can play from this section over here. I kind of start to follow the streamlines if I wanted to as well, and how it interacts with the baffle that I've just created. So what I can then start to do is make changes to the geometry if I wanted to. So if I go back to this geometry here, I can select around, say these components, and I can maybe pull up a radius, so maybe I can start to have more flow going through that region. I can kind of look at these sections over here and understand what if I was to go back and make some changes. So what if I just move that baffle over? And we can see clearly how the flow is changing. So this is a very simple example just to show you guys what can be done with the software, but I want to show you guys something a little bit more complicated as well. So we've got this nasal cavity. So this is similar nasal cavity to what we've been kind of looking at before. So this is just an STL shrink wrap we've given. And with this, I'd like to start my CFD analysis. So I don't need to create any fluid domains. I can just select these components over here and right-click and give it a pressure boundary condition of 0. What I'd also like to do is select this right one and give it a pressure boundary condition of 0. And at the throat, I know I've got a mass flow coming out at around a certain value. So I can very easily go in and change it to, say, -0002. When I hit play, I can start to see the actual simulation start for me straight away. And we can see that we've got results, as I've been talking to you. Like I was previously showing you guys, we can have a look at our basic post-processing. So if we have a look at what the surface is doing, we can kind of take this cross-section and kind of go through this as well, right? So again, as if someone was inhaling air in, we're kind of following the pathway through here. We can see we've got these very fine passages that kind of goes around, and it kind of opens up around here as well. So what I'd like to look at is the maximum value, and I can start to make some changes as well. So I can just start to play with my legend, and I can kind of clearly see areas where I've got high velocity around here. So I've got another model where I've kind of done a little bit more modeling, which I'll show you later on. But what I wanted to do is make a change around this region. So if I pause my model at the moment, again, I'm sure the doctors are going to look at this and tell me how I've absolutely butchered what I'm about to say, so you guys can harass me later on about this. But what if we were to kind of remove that notch? So what if the doctors were able to do something and remove that small notch and really open up the pathways around here? So because this is very complicated geometry, it's not very easy to kind of manipulate like before. I'm actually going to create a spline on this top section, so I'll make this as the first example. Right, so this is just going to kind of follow around here. And I'm going to also make a second section at the bottom, right, roughly to what I can see. So I'm just really roughing it out. I'm not being very good with it at all. And what I can do is just hide this component. We can see these two surfaces I created. And I can, using the blend tool, I can blend them together. Right, so now going back to our model, we can see that, look, it's not brilliant CAD. If you talk to anyone that wants to do a CFD analysis on that, it's just not going to work, quite frankly. But Discovery Live really doesn't care about stuff like this. So if I right-click, I can actually add it to the simulation body. You can see it's very quickly actually added it to the simulation, and we've got flow that's changed around that region. So it's very quick to make some of these these changes in order to understand what we can really do. So let's have a look at something maybe that's a little bit more complicated. So if we go back to our nasal cavity, I've made a couple of changes to this specific one. Right, so it's already going with their analysis, and I made a couple more geometry. So again, you know, if we have a look at the kind of surface around here, we start to play around with the scale. We can just get that to understand. We've got some high velocity regions around here. So we're going from a very large area to a very small area, which is why we've got this increase in velocity. One of the things that I wanted to do is maybe if the doctors can go back and open up that space, we can create this very basic component. We can add it to the simulation body. We can clearly see what happens when that flow gets opened up. So that other component was roughly here. If I remove it, we can see again, very quickly the simulation actually updates. And if we again add it back, we can see how the volume gets added to the flow as well. So a couple other things that we can do is if anyone had any issues with sinuses and we had something right here that may have been closed up, we can add these components as if we were opening up the geometry around this region. So again, if we were to take our model, we'll kind of move it around, and we can roughly see kind of when we're taking this cross section that if we're kind of tracing the profile at the top, we've got a very small region around here that actually connects this nasal cavity to the sinus, which is that big blue open space. So if I've gone in and I've opened up the airways around here, I can very quickly see what would happen if, again, we've got these airways that have been opened up, right? So again, now we've got a larger airflow that's allowing airflow into the sinus, and we've got more flow through that system. All right. Again, one of the other things that we can do is have a look at the flow through the left-hand side. We can see we've got a lot of very thin walls around here, and when we go towards the very back, we can kind of clearly see we've got this asymmetry of flow. We've got more flow on the left-hand side than we do on the right. Now I've got these two components that I'm going to add to the flow, right? So I'm opening up the section towards the front, and maybe the doctors can do something that opens up that whole section as well, right? Again, if we have a look at these things, right-click, we're going to add them to the simulation body, and we can see as I'm adding them to the simulation body, the flow on the right-hand side is updating, and now we've got flow that's a little bit more uniform. So again, I can take a section through again, and I can see that I've actually added this volume to the flow around this region. I can very clearly see, how the flow actually changes around here. So I hope that, that gives you an understanding of how you can use tools like Discovery Live to communicate some very complicated information to someone that may not be as technical. We can make some changes, and maybe the engineers can experiment with different changes that can be made to the model and then go away and do their in-depth analysis in Fluent later on. Or we can run through some kind of parametric modeling as well. Thanks a lot for that, Kiao. I think, do you want to go on or ask questions?
Yeah.
Does anyone have any questions? Go for it.
The first one revolves around sort of the non-linear side of the simulation. It looks like running on a GPU is excellent for relatively linear or weakly non-linear simulations. And I was wondering, if I got that right, or can it handle the full non-linear, like humidity vector density?
So at the moment, so this software has really come out like almost like a generation, almost it's in its like second release. It started out at the start of the year. So just keep in mind there is a lot that will go into it, and I know talking to the guys at ANSYS, there are improvements to it. So at the moment, you're right, it doesn't do things like humidity or conjugate heat transfer, but it is one of those things that's kind of in the pipeline. Yeah. What was your second question? Sorry.
The actual technology limits the amount of non-linearity that you can put in, or whether it would eventually be able to do everything that the CPU solver.
Look, we can't quite say that at the moment. It's kind of, ANSYS have a bet, which is Discovery Live at the moment, when it comes to GPUs. And one of the reasons for that is that if you look at how quickly GPUs are actually evolving, they're actually getting a lot quicker, faster than CPUs. That being said though, it's not as if you can just put everything onto a GPU. When you go into the back end and understand how things are actually partitioned in the core level, it does get very difficult. So it's a bit difficult to say, yes, GPUs are going to be the future and CPUs are kind of going to die off. But this is kind of one of the bets. And one of the reasons for that as well, where this is why we're saying it's not going to replace Fluent or any of your flagship solvers. At the moment, it's used as your first pass analysis, not your final design.
My second quick question was, so it looks like you can create a simulation and sort of send it, as it were, to someone. So how does that work? Do you send them an executable which has some code buried in it?
Well, you send them this file. So this specific file is just a space claim file. So if I just go File, Save As, it will save that out, right? So I can just give it a different name. So if we go New, and I can just go File, Open, go into the new one, and it's pretty much just going to reopen it up. So they obviously need the software, which is Discovery Live. But yeah, if they've got it, it is something you can just send them the file, they can check it out. I didn't talk about parametric sweeps or anything like that, but it is also something that you can do and you can actually send to someone else. Yeah.
Is there any plan to deploy Discovery Live through a web browser so they don't have to install that?
They did try to do that. I think the biggest issue there is streaming. So when it actually first released, it actually was available for you to stream. But I think one of the biggest issue is I think it comes down to Australian internet. Like the pings were really high. So if you're in somewhere like North America where the servers were in Singapore, it was great. And you can do something like that. At the moment with kind of Australia's infrastructure, we really didn't see that happening, which is a bit poor, but I think it's also something that's changing very quickly with 5G coming along as well. And NBN being a lot more viable. I'll make a call, I'll let him know. I've got him on speed dial, no issues.
I can add a little bit to that. CSR 20 years ago tried something called online CFD. So we ran for almost 8 months, but the problem was the uptake was pretty bad. Even though the back then was pretty bad, but still the uptake was bad because back then CFD was considered to be a very specialized. So a lot of the companies it doesn't run on a host computer, but it's running on the cluster.
Yeah.